Hello everyone. Today let's solve the problem Mike and GCD problem, right? So this was asked in the Codeforces around 410 division 2. So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So let's see what the question states here. Just give me a second. 1 second. Yeah. So we are given an array A, right? So we are given array A and we need to make it beautiful, meaning the GCD of all the elements has to be greater than 1, right? So the GCD of all the elements uh, from 1 to n, suppose all the elements means the elements that's given, right, in the input. Basically the GCD of all the elements has to be greater than 1, then only it's said to be beautiful. We have been given array A. What we need to do, we need to make it beautiful, meaning the GCD of all the elements greater than 1. So basically the allowed operations are here. In this case we have to choose the consecutive pair ai comma ai plus 1. We have to choose the consecutive pair ai comma ai plus 1, right? So this is one thing, and we have to replace with ai minus ai plus 1 comma ai plus ai plus 1, right? So this is the main thing. We must check if the possible, if it is possible, and then we have to find the minimum operations, right? So we have to check if it is possible and we have to find the minimum operations. First thing is, if overall GCD is greater than 1, see here, if overall GCD, if it is greater than 1, then it is already beautiful. Then it is already beautiful. In that case, we need to return 0. That case, we need to return 0, right? Otherwise, we have to minimize the operations, right? Otherwise we need to minimize the operations. To minimize the operations, it is best suited for DP, or the dynamic programming, right? So let's go with the DP itself for this, to minimize the operations. Basically, since operation affects parity, solution reduces to handling odd or even numbers optimally, right? So again, we are given array A, first thing, array A in the input. So we need to make it beautiful, meaning GCD of all the elements has to be greater than 1, right? So allowed operations are, we have to choose the consecutive pair ai plus 1, replace with ai minus ai plus 1 comma ai plus 1, right? So we must check, uh, just give me a second here. 1 second. This one, replace, I'm speaking of, right? So this one basically. So this is fine. Um, we must check if it is possible, and then we have to find the minimum operations. If GCD is already greater than 1, then it is said to be already beautiful. Means we have to go with 0 operations then. If GCD is already greater than 1, uh, then we need 0 operations, right? Otherwise, we will be making use of DP to minimize the operations. So again, I'll tell you now itself, we'll be making use of the dynamic programming just to minimize operations as per the question, right? So just keep this in mind. We'll be going with dynamic programming, right? So let's come to the input output part here. 1 second, let me delete this one. Yeah. See, this is nothing but here, this one. What we have to find, the this is array A, right? So uh, this one is nothing but the number of elements. 2 is nothing but the number of elements. See here, 3 is nothing but the number of elements. This is array A, capital A, right? Array A. Same thing goes with here as well. 2 elements, array A, right? So here, this is array A. We have to find the GCD and we need to return the output here, right? So here you can clearly see, man, this is GCD of 1 comma 1, right? So we can directly go with this one, 1 itself, right here. So this is not greater than 1, it is equivalent to 1 here in this case, right? So we need to return S1. We can directly guess this one. See here, here as well. See here, we have 6 2 4, right? So we will be going with this one approach, GCD of 6 to 4. GCD of 6 to 4 is nothing but 2 here in this case, right? So which is greater than 1. In question they have strictly mentioned if GCD is greater than 1, it is already beautiful, and in that case we need to return 0. See here, we have to return 0 in this case. Yes, along with 0. Yes, we need to return in the first place, and 0 we need to return second, right? So same goes with here this one, 1 and 3. GCD of 1 and 3 will be going with a 1, and we need to return s along with a 1 because it is not greater than 1. We'll be going with s and 1. Right? 1 and 3 are similar. In the case of 2, here this one will be going with a GCD of 2 comma 4 basically, which will be basically GCD will be 2 of 6 to 4, which is greater than 1, right? Which is greater than 1. So GCD is quite obviously when GCD is greater than 1, what we will be doing? We have to return 0. They have strictly mentioned in the question, right? So again, let me tell you, this is the approach basically. GCD of 1 comma 1 is 1, right? So this is not greater than 1, so this is not beautiful, right? This is not beautiful yet, right? So let me write this one. This is not beautiful, right? So both are odd numbers here, right? So both are odd here. If two consecutive odds exist, then one operation makes them even beautiful. Means even basically. If two consecutive odds exist, see here, two consecutive odds exist here, right? 1 comma 1. If two consecutive odds exist, then one operation makes them even, right? One operation makes them even means it makes it beautiful basically in simple terms, right? So answer will be 1 itself in this case, right? Same goes with this one as well. Same goes with the third one as well here. A we have 1 comma 3, both are odd. Here see 1 comma 3, so we have to go with GCD of 1 comma 3. Second one is crystal clear here. GCD of 6 to 4 is 2, which is greater than 1, so this is already beautiful. We have to return 0, so this is fine. Here now we know why we got 1 along with the yes. So here in the this one, for the third one, we will be going with a GCD of 1 comma 3, right? So both are odd, and adjacent one, basically they are adjacent, right? So one operation makes this one both even, right? So same as this one, right? So this is not beautiful because GCD is 1 here in this case. So as I have said, here in this case, this one, two consecutive odds exist here, one operation makes them even, right? Currently it is not beautiful, but as I have said, two consecutive odds exist, so one operation makes them even here, nothing but this becomes beautiful. So we need to return 1 in this case. Along with the yes, we need to return 1 in this case, right? So yes, we need to return at any cost. Along with that, we need to return 1. This is fine. So this is the approach that we will be going with basically. Simple one, man, right? Very simple. Let me delete this one. So I hope the approach part is completely clear, man. Let's do one thing. Um, as we are completely familiar with the approach, let's discuss the complexities part here itself, right? So here in this case, what will be the time complexity here? Time complexity would be big of n. So why it is big of n? Because we will be going with a single pass for GCD as well as the DP, right? So we will be going with single pass for GCD and DP, right? So overall time complexity would lead to big O of n, right? So what will be the space complexity then? Space complexity would be a big O of n. You would have already guessed this is for the DP array that will be making use of, right? So this is for the DP array that will be making use of, right? So the time complexity and the space complexity for the code that will be writing in the future would be big O of n respectively for both, right? So this is fine. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So I'll just come here. Just give me a second. So I'll just come here. Let me come to the compiler. First thing here would be we will be going with a fast input output. So I'll just import here input output package. So java.io start. This is fine. We'll be going with a different utilities as well. I'll just go with util.start. So this is fine. Next, let me go with the class main. So within the main class, so let me go with main method here. So I'll also make use of the input output exception. This is fine. Now let's do one thing. Let's go with a fast input reading, right? So I'll just go with the buffered reader here. This one will be new buffered reader of new input uh, stream reader. So this one is fine. System dot in. Yep. And let me go with print writer. This one will be pw. It's new print writer of this one system dot out. So next, what shall we do? We have to read the size of the array as well, right? So first they have given size of the array itself. So I'll just go with here int n equals. So which is of the type integer. Basically, I'll just go with a integer dot parseInt of we have made use of the buffered reader. Let me go with read line. Next, let me go with array here. Array dot stream buffered reader. So this one will be read line. Sorry, one second. Yeah, read line. So let me go with split here because we have space. Let's go with the split here. This is fine. Did I miss anything here? Oh yeah, this one I shouldn't be closing this one here. I should be closing this one here. This is fine. Now let me go with mm, map to int. This is fine. Next, within the map to int, let me pass integer. So this one, let me give parseInt here. This is also fine. Let's go with to array. To array. Right. So this is fine, man. We are done with the input output part. This is it for the input output part. So let's come to the main logical part here. First, let's compute the GCD of the whole array. So I'll just go with g equals 0. Initialize g equals 0 first. So let's go with the iteration here. This one will be simple x of array. Individual numbers of array we are considering here. G equals. So I'll be going with GCD of g comma x. Right. So GCD of g comma x. So this is one thing. Before moving on with this, so basically GCD, I haven't written the GCD helper function itself, right? So we need helper function. So let me write this one, a static int GCD. So this one will be int a comma int b. This one I have template actually. I make use of the template for the GCD. This is fine. So let's return here if b equals 0, then we have to display a, else GCD of b comma a modulo p, right? So this is for the GCD, right? So we have solved many problems using the GCD already. So this is fine. We have already made use of the GCD within the for loop, right? So this is fine. Now let's move on with the further steps. So now yep, we have to always means just give me a second here. So it is always possible to make the array that's given in the input beautiful. They have mentioned in the question. So we have to print yes in the first line always, right? So let me go with a print writer dot here. This one, let me go with println. Println of let's print yes. So it should contain yes in the first line of the output every time. See here. Yes, here this one is S as well, this one is S as well, right? So this is fine. Now, this is fine. Next, let's do one thing. Um, if it is already beautiful, then we have to uh, mention 0, right? So if GCD is greater than 1 means if it is already beautiful, then 0 operations are required. We have to print 0 in that case, right? So we have already discussed this one in the approach. So G we have considered, right? If G is greater than 1, here I'll just go with pw dot println. We have to print 0. This is simple, very simple, right? Else what we will do, so else what we did, so we will be considering the DP array here. So DP of I equals minimum operations for the prefix 0 to I, right? So that is the reason to calculate the minimum operations will be uh, using we'll be making use of the DP. That's what I said while discussing the approach, or while discussing the question itself I said. So we'll be making use of the DP just to minimize the operations, right? So for the prefix 0 to I basically, right? So let's articulate the same thing in the form of code here. So this one int DP equals new int of, let me pass n here. This is fine. So this one will be arrays dot fill dp comma, uh, let me pass int here. This is 1 into 10 to the power of 9, right? So I'll just give here 1e9. So this is large initial value, man, don't get confused here. This is fine. So let's move on with the further steps here. Let's go with the base case. If the first number is e1, that is nothing but 0, uh, we have to go with 0, else we need two moves, right? So I can just write it on this way. If dp of 0 equals, so this one will be array of 0 modulo 2 here in this case. If it is equal to 0, value 0, then we have to print 0, else we have to go with 2, right? Nothing but uh, if first number is even, then we have to go with 0, else we need two moves, right? Simple, right? So let's move on with the next step accordingly, what we have discussed in the approach. So we have to build the DP here. So this one we didn't discuss in the approach. Basically, let's build the DP. So let's go step by step as we are dealing with the dynamic programming. So I'll just go with I equals 1, I less than n, I plus plus. So if here this one array of I basically modulo 2, this is equal to 0, then what we need to do, so even number carries forward same cost, right? So this one will be, I can just write it in this way, I believe. So I have to go with the previous number, right? So dp of I equals dp of I minus 1. I hope this works, man. Dp of I equals dp of I. So even number basically carries forward same cost, in the sense we have to go with the dp of I minus 1, I believe. Let's see. So I'll just go with else, sorry. So else, if it is odd number, then odd number normally adds plus two moves. So this we know. This one I can just write it in this way. dp of I equals dp of I minus 1. As it is odd, we have to go with a plus 2 here, right? So let's go with the optimization. Nothing but if the consecutive, if we have the consecutive odds, then we have to go with just plus one more. So this we know from the approach. Let's optimize this one, right? So I'll just go with if array of I minus 1 modulo 2, this one, if it is odd, right? If it is equal to 1, then dp of I, I'll just assign this one to math.min dp of I, this is fine, comma, I greater than 1, this is also fine. This one will be dp of I minus 2, this is also fine, else 0. This is plus 1, fine. We are almost done actually. Now we are left with only one thing. We have already written the helper GCD helper function, right? So answer is nothing but dp of n minus 1, right? So we have to print that one. So I'll just go with print writer. So this one print ln of, just go with dp of n minus 1. So this is fine. Finally, we have to flush or close here. I'll just go with print writer dot close. Can either go with a flush or close, right? So it doesn't matter. I'll just go with a close. So we are done with the coding part, right? So this is it. This is it for the code, right? So before checking the code with different inputs, so let me copy paste the signature starter template. So I'll come here. Let me paste this one. Let's move on with the logical part. Let me come here to the question. Let me copy this one input. We have to get the output yes one, right? So let's check. So we are having a misspelled buffered here. Line number 24. Yeah, this is fine, right? So now again this one as well. We run this one again. Error cannot find symbol. Int array dot string. Line number 28. This is fine. Int array equals array dot string variable array location. Cannot find the symbol. So this line is, so this has to be arrays actually, not the array. The term arrays, right? So I have misspelled here again. So now, yeah, here also I have misspelled map. Let me remove one A. So yeah, now we are getting the correct output. So many typos. See, this is fine. Now let me copy this one. We have to get S and 0, right? So for the second one. So we are getting the correct output. So let's go with the third one here. We have to get S1, right? So let's check whether get the correct one. Yeah, output S and 1. So this works absolutely correct for all the inputs they have mentioned in the question, right? So this is fine. Let me copy the entire code. Let me hit the submit button here. Let me paste the code. Let me choose C from here and let me hit the submit button one. Wait, why this is not taking? Yeah, I hope this works for all the test cases, man. Let's see. Oh, this is very slow actually. This is running. Let's wait for some time. This is simple, right? So we went with the GCD calculation plus DP, right? So let's wait for some time. Yeah, here you can clearly see in the toast it is showing accepted. The verdict we got here is accepted. Means whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the question, this one approach and the complexities, right? For now, this is it. Thanks for watching, guys.